Good afternoon, and welcome back to the Net LOL podcast. Brent Salisbury, Kyle Mestery, Dave Tucker, and myself, and welcoming our esteemed guests today, Dino and Dave. Thank you guys for joining us today.
Thank you for inviting us. Great to be here with you guys.
It's good seeing you guys again. I mean, it's been a while.
Yeah, it's great to be here.
I haven't seen you guys on camera or in person for a while.
For a long time, yeah.
So what do you, just to kick things off a little bit, like what do you guys been up to? Anything interesting?
Go ahead, Dino.
Oh, okay. Well, let's see. I've been doing contracting since I left Cisco in the end of 2012. And, I've been doing my Lispers.net thing where I have an open source implementation of Lisp, and it's been put into a lot of different use cases. Particularly, we've been playing with it with the Olympics. I contract with NBC Sports, and so I've been to the last few Olympics, and we've tried different Lisp-like things. But what I decided to do in April during this coronavirus thing is I go, what can I do to help the world? And I go, I don't know how to do anything really except for code, so I might as well start writing some code. So what I decided to do is I built something called CT Lisp. Could you imagine what that means? It stands for contact tracing using Lisp. And so I built
awesome.
I built a bunch of applications that run over the Lisp control plane, and basically using the Lisp mapping system as a distributed database. And I've been able to scale it to 10 million entries, so that's quite interesting. So the Lisp part is boring. It's all the applications of keeping track of people and associating health state and location and building perimeters around people so we can notify them when they're in exposed areas versus safety areas. And we just keep building new sort of applications as we've been going along. And a lot of people seem to be interested in it. And there's just a few of us working on it, but it's been kind of fun. So the only thing is now it's starting to turn into a business. So you know how the fun factor changes. Now it feels like real work and company stuff versus just creating and building and testing and stuff like that. So that's
cool,
what I've been up to since April.
Yeah. Well, it's right there on the name, locator ID,
That is awesome.
Right, exactly. Yeah.
That's really cool.
It's a great way to take networking, right, and make it useful for humanity. That's super cool, Dino.
It's awesome.
Yeah. I mean, we know so much about scaling as networking guys, and if you want to be able to trace 10 million people or something like that, why not use the tools that we learned in networking, right?
Scale,
so we'll see how it works. Yeah. So I mean, if you guys,
60 million,
if you guys want to
introduce you to the UK government,
It's great. Yes, we've already talking to the UK government and many other governments, but. And it turns out the biggest challenges are never technical. They're always political and human-based and social and stuff like that. But if you guys ever want a presentation, I could give you a prezzo and show you how it works and stuff. And of course, if you want to beta test the mobile app, you're welcome to do that too. So Dave, if you have some testing cycles left in you, you could rewind the days of the past. So.
Oh my gosh.
Yeah. I'll give it a try.
Let me say something, cool. Dino, though. You reminded me of something. I don't know if you're going to remember this, but when we first started doing Lisp, so Lisp is like, there's no magic. Like Dino said, get over it. It's an encapsulation. You said that about IPv6, but it was the same, right? And,
right.
And I remember the exact moment when you said that. But you also said that you told me, should we do a Lisp implementation? Remember that whole discussion we had about that? And what you said was really enlightening to me, which was, hey, it's an encapsulation. I've done thousands of these, Tuba or whatever. What's interesting is the database. That's what you told me when we were first starting. And when you said what's interesting is the applications, it's kind of like it's congruent with that somehow. It's like the underlying technology kind of fades away in interest, and what you can build on top of it becomes more interesting.
it's an enabler, but then because it's done such a good job, or it's trying to do a good job, you forget about it. It gets commoditized, right? You know,
Yeah,
and I think
yeah.
like we were talking about before the recording, a lot of people don't know what this internet is. All they know is that they can actually talk to anybody in the world anytime.
Yeah.
And, you know, that putting something together like that has never happened before. We've had
That's
phone
amazing. Yeah.
networks, but they were all country based, right? And do you guys remember traveling like in the 70s and 80s and going from, you know, one country to the other in
Oh
Europe
yeah.
where you had to actually, you know, have phone cards and long distance
Oh,
and
it's disaster. Yeah.
remember the connector bags you had to bring with you to connect up to the modems in the hotel rooms, right? You had your power adapter bag and you had your
Oh
phone
yeah.
connector
Oh
bag.
yeah.
Oh
You know, I
yes, the
haven't
power
thought about
adapters.
that. I haven't thought about that in maybe 25 years at least.
Right,
I had a
right.
power adapter catch on fire on me once. But speaking of the
Yeah.
internet, I mean, this is one of the things. Like the folks listening, if they don't know, I mean, they can thank these two guys partially for the internet working today. You know, you guys have done contributions that make what we're doing right now actually possible. You know, and that's
It's
Well,
cool.
yeah,
It's cool.
that's
yeah.
really cool.
You know, of all places, I wrote about this on Facebook, and I got like millions of people talking about it. But what I said was, and this was early in the pandemic, but I was thinking about you know, we talked about this a little bit before the recording too, about the M-bone. And there were these internet pioneers. This was right when just a little bit after I came into the internet thing. It might have been like 90, well, let's see.
Late
It
90s,
was,
wasn't it?
no, it was
Early
90,
90s.
91,
Oh
90,
wow.
91, 92,
Yep.
something like that. Well, you didn't read
Mhm.
that URL I sent you, Dino, but CJ had said, well, when did you meet me? And I tried to figure it out. And it was at Nanog 6 when I was giving a talk about the DVMRP PIM, you know, thing that you built because I remember. Okay, so
That
there's
was
the M.
okay. So that
Let
was
me
mid
give it a little
90s.
backbone.
Yeah, yeah.
No, it was 92 or
92. Okay.
93, 93, Nanog 6.
Okay.
Anyway, what happened was I got into this, long story, but anyway, I got into this multicast thing. I met Dino. We started doing some PIM stuff, but the whole multicast world was DVMRP built through this M-bone thing. And what we needed was, okay, you connect up all these things, just like today. It'd be like BGP and your IGP. What we had was the M-bone DVMRP as the transport network. But inside, what we wanted to do was inside our enterprises, we wanted to run PIM dense mode. So how do we do that? And I said, Dino, we need code for this. And so, of course, he built the code. Because next week, I'm like testing it. And then I gave a talk about it at Nanog, at Nanog 6, which was in San Diego, Nanog 6, right?
Okay.
You know, and I gave a talk about it. And if you look up Nanog 6, you can find the talk. But it was, yeah.
So, you know, it's funny, during that architecture, we never uttered the words overlay, but that's essentially what it was.
That's really what
Isn't
it
it
is. Yeah.
funny how every 10 years a new acronym comes out, but the fundamental principles are pretty much the same. We tunneled a lot. In fact, to get a lot of that PIM stuff to work, we had to use PIM over GRE tunnels as well. So
Oh,
it's
yeah.
just like DVMRP tunnels, GRE tunnels. We were building overlays. The M-bone was an overlay on the internet, obviously, right? It didn't it didn't do multicast as well as we wanted it to, because multicast to us in its most efficient form was, you know, a router splitting up a packet and putting it out to physical interfaces. That was the panacea. That was the utopia, or whatever we wanted to do. And we realized that it was really hard to get to there. And after all these years, I realized I'm still doing multicast, and I'm doing it from cell phones, but it's on overlays now. And what I realized is what was important, Dave, was not that we replicated at the interface level. What was important was the service model that multicast gave us, like we're doing right now. This is a multicast service model. 6 people want to join at a certain time. We are rendezvousing through a calendar invite that said join Blue Jeans at this time, you know, and we're all on different time zones. And that's what we tried to do at the router level, right? But I think the service model was so key. The fact that you could join something or not allow somebody to join, or to remove somebody, i.e. joins, prunes,
And
these
it's funny.
admission control,
There was a control plane. There was a control
And
There
plane
was a
for it.
control plane, yeah.
Yeah, it is a
Yeah.
control, and it's funny because, like, Dave and Brent and I just had a thing internally where we're talking about the Paxos algorithm, and we had a professor come in and talk about his paper about it. And it's really funny because on the side chat with the team, all the networking geeks were like, "This is just like multicast. This is just like," and it's like what Dino's saying. I mean, there are encapsulations, there are tags and tunnels, but it's, more things change.
So,
The more
so
they
two
stay.
things. Two things. When I'm just thinking, Dino, every time we do this, you remind me of so many things. It's great.
Good.
Anyway,
I'm glad I'm triggering those long-term fetches.
when I first came into the IETF, I didn't know about multicast, and then as time went by, this whole, about a year. As time went by, it's about a year, not 30 years like it is now. But so I got to know Steve Deering, and one of the things he told me early on about multicast, and I'm sure you've heard this, Deering. I'm sorry, Dino. One of the things he told me early on about multicast is he goes, and this was like in 91, say, he said, this has stuck with me for all those years. He said, the internet was a hostile overlay on the telephone network. Multicast is a hostile overlay on the internet. That's the first thing.
And that's what we called MPLS, by the way. It was a hostile overlay on ATM.
Yeah, but that the insight of that.
It's funny you say that. Yeah.
It had the technology piece of it, but he understood the business, the culture, and there was so much in that. Unpacking that would take, Okay, so the other thing I wanted to say, like you said, Dino, everything's an overlay. So we had this IAB thing in Amsterdam. A lot of people were, stoned, face it, including
Amsterdam,
Yeah. But we had a really kind of interesting IAB retreat or get together or something in Amsterdam where we talked about the routing and addressing problem, and it was at that workshop that the LISP thing was born. Is that correct? Are you with me so far, Dino?
October
right?
2006.
I remember this.
Yeah, 2006.
Story. Yeah.
And
you know why?
And what was the name of the hotel?
It was the Swiss Hotel. Wasn't it the Swiss Hotel?
No,
on Town
that's
Square?
where you and I stayed there a couple times. But it was Daryl's favorite hotel. Begins with a K. It was right off the square.
Oh, it was the Kras.
The Kras.
I didn't know we went. Okay, it was the Kras. That place is great. Okay, so anyway, this is what happens. We're trying to work with the ISPs of the era. It's like whatever 2006 era. By the way, I can always remember that because Jack was born right after that in November of that same year.
First grandchild. Yep.
Yeah.
Mm-hmm.
By the way, he turned 14 yesterday.
I hope you got him a new set of Chucks.
I got him all kinds of stuff.
But Chucks are critical.
Yeah, well, yeah. But anyway, so let me finish this thought. So anyway, Dino, sometime later, Dino, we started talking. I don't know what we were talking about, but anyway, he goes, we want to call this thing LIST, Locator ID Separation Tunneling, LIST. And I kind of said, well, what's not encapsulated and what's not tunneled? Even like TCP packets are encapsulated. So you should just call it LISP, because I had a long history of trying to make up names in the IETF that didn't really mean anything. It's like glop addressing. Actually, Peter Lothberg helped me with that one. But, that didn't really mean anything. And so I had a long history of that. And then when the opportunity to get an acronym that meant something else came up, somehow was attractive to me. I don't think it was a good idea, actually.
So Dave
the
coined it, and then
the name?
we thought those 4 letters were great. So we were doing every permutation of it. And one of them that came up was SLIP. Do you remember the serial line
Yes.
interface protocol that ran up.
Yes.
So we said we're not going to call it SLIP.
No,
So
but it was Lisp, so
you know,
there were proposals like cons and coulter and all these
oh
Lisp
yeah,
things. You know,
Wow.
yep,
I
right.
was, I don't know if it was a
Lisp
good idea, but it seemed
ListConf
clever
was
to
a
me at the time.
control.
I
It
remember
was a
when you guys
control plane. Yeah.
finalized the name, because I'd actually done some actual Lisp coding when I was in college, and I had some
Ah,
really
yeah,
bad flashbacks. I was like, oh my God, parentheses.
See,
But
yeah,
I remember Lisp. So Dino, I remember you presented at Google about Lisp. Maybe it was like what, 2007 or 2008. I mean, I had just
yep,
joined Cisco in 2006, and someone
yep,
published it internally. And I remember watching you present to all
yep.
these Google
Dave
people.
was there, Vince was
Dave,
there, Daryl was there, all
it
four of
was
us.
it was
Yeah.
amazing though. I remember watching that, going like, wow, like that's what I want. That's so cool. Like the whole
And
concept is cool. The way you
there
presented.
was this young guy in the first row, and he was asking all difficult questions, and he was kind of a hot shot, but he was super brilliant. His
Yeah.
name was Lorenzo, and we all know who Lorenzo from Google
yeah,
is now, right? The IPv6 on Android guy.
yeah,
So,
yeah.
these guys saw this stuff early on in their career. So, but
Well,
yeah, so
I think it's funny that you
And
guys
hey,
like you steered away from tunneling because back in 2006 I was on the ops side and like we used tunnels when every other option was exhausted and you had a disparate network that maybe you didn't have control over and it was garbage in between. So let's abstract that away. So like
well,
back then
when we
tunneling was kind of like I don't know. I think it had
uh,
a connotation on the ops side, whereas nowadays it's
so
nobody gives a
so
damn.
Brent, I don't know if it was a bug or a feature, but when we first did GRE tunnels, we wanted those point-to-point links, and later they became multi-point links to be part of any other interface topology that was part of the routing system. And of course, we always had this recursive stuff because you had to have the OSPF route to realize the tunnel. But then if you ran OSPF over the tunnel, you would kill your route, right? So you never wanted to mix the underlay and the overlay. And the fact that we learned that later by when we did Lisp, we just called them dynamic encapsulating packets. No different than if I'm an IP router and you're an IP router on an Ethernet, we're encapsulating in an Ethernet header. So, Dave, started the whole conversation with it's just another header in front of it. And the fact that we made tunnels look so hard, meaning setup time, and just even with MPLS TE tunnels, there was so much setup. And even today, people talk about. I wish we wouldn't even had the word tunnel in the protocol for any of our definitions
Yeah.
because we're just putting a header on it, and that header changes depending on a lot of different things. And so they're really softer state sort of encapsulation mechanisms, and they're dynamic. But the GRE thing was crazy, and then to be able to build a traffic engineering tunnel that didn't really run over IP, it ran over this 2.5 protocol called
Mm.
NPLS, was something completely different, right?
Well,
So,
I
but
was thinking back
everything's an overlay.
when I joined
but
Cisco, and I was early on in whatever, 99, around that time. I remember having similar thoughts about exactly what you're saying, Dino. When I looked at like, well, we've got ATM interfaces and frame interfaces, and now we've got they were multicast interfaces, and that's why do they need to be special? Why isn't it just the IP interface and send all that crap over the same thing? It's just a different encap, right? And
Excuse me, how about the 5G network right now? Why is
yeah,
that so special?
what a
It should
disaster.
be
Yeah,
just
like
another layer 2 network, as you said,
yeah,
and why do we have all this
it's
stuff?
not. It's not. That's the part where it's like I've spent more time recently. Is that's a business thing.
that's a
The
yeah.
whole,
Oh, absolutely.
it's a business thing.
We've been
It's not a
saying this
Yeah.
technology
since
thing.
2G,
Well,
right? What's wrong with
I'll
IP?
tell you, they've been very successful because they've gone to 5 versions where IP can't even go to a second version, right? So
Right.
maybe they figured the business thing out much better than the internet did, right? So,
Marketing.
or maybe
No,
the
no,
internet revenue happens at a higher layer. So,
no. But okay, two things. You remind me of so many things, Dino. I love talk. So you guys keep doing this because the only time I talk to Dino
because
is
all these
on like
electrons are firing in his brain.
Right.
podcasts or things at NLNOG or something.
Yeah,
But
and for those of you at
one of
home,
the things.
real quick, Dave, you're my network shaman, so I recommend you take some peyote before. Go on a spirit walk with him.
How you know he hasn't already?
Which Dave are you talking to?
You,
There's two.
you're my network shaman.
DMM.
I know. You know what? I'm not a professional. Like everything else, I stumbled into it. No, genius plan or anything. I just fell into it.
But you're
I tripped on
resilient.
it. I
You're an
tripped on it when it
adapter,
was in front of
right?
me, and I fell
There's a
over,
talent
and
and
people
skill for that.
That was one of the lessons Dave taught me was like, you got to figure it out as you go.
I tripped on
you
it,
can
man.
try to pre-plan it, but it's a waste of your time.
Well,
Hey, there's OSI and there's TCP/IP, right?
Yeah.
TCP/IP
I was there
figured it out
then
as it went
too.
on.
I was there then. You know what? I was there then. That was right when I came. Thanks for reminding me. Ross Callan.
Yeah.
That's all I have to say.
Yeah.
Right?
Right. Yep.
Right there. I was there. I mean,
and to
I
give
walked
Ross
into
credit, he brought a lot of ideas from OSI into the internet that helped the internet, right? Subnet masks, longest match lookups. That all started with NTAP addresses.
Yeah, but on the other side of that story is PNNI.
Yeah, right.
Yeah.
Not to, how to overcomplicate it already complicated link state protocol. Yes.
Yeah. Well, the road is littered with those. I mean, that's what we're talking about, figuring out as we go. Look at anything we did. Like, Jesus.
Yeah,
BFD,
you have to have failures.
Right? Let's look at the simplest thing that any of us have ever worked on. Is probably like BFD. Like, how much simpler can it get?
Yeah.
Have you seen it today? I mean, like it's turning into.
Oh no, I haven't seen it today. Now it's like PNNI. It's growing and growing.
It continues to grow. Yeah, I mean, people want to put in performance monitoring and all kinds of shit. It's like, you missed the whole point. The theme at the beginning was simple.
This might be a good thing to talk about. They say a great architecture is not when you could put more into it, is that you can't take anything out of it, right? So the question is, do you build like we did with the internet and you go incremental, and because you go incremental, things pile on? Or do you have this grand vision and you make it rigid and you say it's going to be that and nothing else?
That might be the difference between 5G and IP.
Yeah, it could work. But the thing is you got to deliver it fast. It can't take years and years or you obsolete yourself. I always remember this when I worked at Procket and the chip guys were working. They said, if we can't get these chips out in 1 year, by the time we get it out, you're going to say, why are we running on, 50 nanometer when 15 nanometer is going to come next year? And the density of chips and transistors and stuff like that. So you have a timing window. And if you don't make it, your stuff's old when it gets out, right? And so you can't do that. And so I think the best part of TCP/IP is we did make mistakes and we did deploy the mistakes and we tried to fix them right away. Look at the BGP3 to BGP4 transition. A bunch of guys got in the room and said, I'm going to type this in, I'm going to type this in. And the internet converted to BGP4, right?
The TCP thing is what you said. It's just an encap. It was really the implementation algorithm, right? The slow start algorithm.
So there's a really cool. There's a really cool.
Right? Yeah.
Yeah, Van. I was lucky enough to. I mean, I had so much luck in my career in the internet. I personally knew Van Jacobson and had many conversations with him. I mean, how fantastic is that? Okay,
frighteningly smart guy.
No, he's not like a normal human.
That's what I mean. Like frighteningly.
I mean, and he's not. As smart as he was, I never felt he was condescending or looking down on me or anything like that. He helped me with a lot of stuff.
And he wasn't a computer scientist; he was a physicist.
He's
That's
a physicist.
Where he started.
Yeah. Well. So here's what happened. He told me all about this. Okay, so he's working at LBL. And the actual NSF node was at Berkeley, right? Check me on this, Dino. It was on Berkeley, right? And so they were trying to jam a bunch of data up over TCP, what was then called, which was that version of TCP/IP. And of course, it didn't work. And so he starts looking at it, and he's going, well, I'm a physicist. Let me apply a fluid dynamics model to this thing. And the result of that, he could describe this to you. It's a beautiful thing. The result of that is the congestion window variable in TCP.
Yeah.
And he does it with one variable.
And that's how we look at queuing now.
It's fantastic.
It's kind of a fluid problem, right? Filling the bucket and emptying the bucket.
But I mean, this thing is so.
But it just wasn't.
I taught a class on the internet at Oregon for I don't know how many years. And one of the things that I always said allowed the internet to scale was that instant where Van Jacobson put this physics that he had in his mind into the network.
If one line of code could do it, that was the line of code.
That was one of them,
Right.
yeah.
No, the internet today without that wouldn't be here.
Yeah, it's like CIDR addresses.
Right,
too.
agreed.
I mean, that was
essentially
one of those revelations too, right? I mean, there were a bunch of these key things.
We were also lucky enough to work with the inventors of that, Vince, right? And Tony, of course.
And Tony.
But Vince, we work with Vince a lot, or I got to work with Vince a lot. I was really fortunate. But I mean, one thing that Van did, that was a huge milestone in the evolution of the internet, and it's so brilliant because to be able to encode so much information in so little code. He was a master at that, by the way. I can give other examples. Let me give one other example.
It's not science. It was art too. It was beautiful.
Oh, yeah.
This code.
Beautiful.
Yeah.
Beautiful. Let me give one other example. Okay, so we had these tools on the M-Bone, VAT, Vic, and VAT was Van's audio tool to run on the M-Bone. And it was super sophisticated, and had these elastic buffers and did all. I mean, it did this stuff decades before.
And it had a good UI on it too, Dave. Remember?
Yes.
UI was simple and intuitive to use.
And it would run on everything, right?
I used it when it was around. It worked pretty well.
Yeah, well,
on my Spark station way back when, yeah.
Okay, so now I'm going to tell the Spark station story. So, I was a beta tester for Solaris 5.0, which was SunOS 2.0, I think. And I had it I had two boxes. One was a Spark 5 and one was a Spark 10. So on the Spark 10, that would run, fine. But on the Spark 5, under certain conditions, it would panic the kernel. How you have an application that can panic the kernel, that's a whole nother question, right? But okay, so I give the source of that because this predates open source, but of course he didn't, his code was available.
It's code, who cares? Yeah.
It was kind of called public domain back then, right?
Public domain, yeah.
Yeah.
And so the Sun people, they can't figure out what's going on. And I said, okay, can you send me a CD with a CD, literally, not DVD, CD.
CD.
And then with the source code on it. So they, I was a beta tester or whatever. So they sent it to me. I look at it, I can't figure it out. And so I called him up. I said, hey, can I send this to Van and ask him if he can figure out what's going on? And they said, yes. So I sent him a pointer to where it was, or is an FTP or whatever in those days. And, he fixed it in about, I don't know, from the time I told him till the time we had the patch for SunOS, which he had never seen before, by the way, no more than 5 hours, no more. And I don't know if he went to lunch, whatever he did.
Well, the theme was code there. Remember, Dave? I remember when I first started going to the IETF meetings, the first few I went, people were still using those freaking transparencies with the marker on them, whatever the overhead.
Oh, I think, Tom, I think you've heard me tell this story a million times, but I'll tell it.
You told me a story of this, but there's the one where
the Van one. Yeah.
He brought a bunch of code he wrote on these overhead slides.
No, let me tell the story
in real time.
In real time, yeah. Well, I don't know, but I'm sure he did that. But let me tell for your listeners and Kyle, Dave, and Brent the story. So I'm at the first IETF I went to, and I really didn't know that much about networking. I think this might have been in Columbus, like maybe 91 or something like that.
Okay.
So I don't know what's going on. I don't know anything about networking. I was kind of an enterprise networking engineer at University of Oregon, and we had stuff like Apple Talk and IPX and DECnet and that kind of stuff, And so I wanted to go to the IETF, but I can't remember how I got the idea. Anyway, finally I convinced my management, let me go. And so I go, and I'm sitting there, and I think it was an IntServe, not DiffServe, the pre-DiffServe or IntServe, when they thought they were going to set up this hard state all over the network for them. Mm-hmm. And so I'm watching it, and there's this guy talking about this person's thesis at MIT, this guy named Perek, And what he did was he essentially discovered that you could do flow isolation with WFQ. You know, that's what he discovered. But he did it on his thesis was called something like multiprocessing or multiprocessor sharing.
I read the paper. I know what you mean.
You know, and so I'm sitting there, and so everybody was trying to implement this stuff to do QoS, basically, right? And so there's some guy, first working group I'm in. First off, Dave Clark was chairing it. I don't know if he was the chair of it, but he was chairing it that day. That was the first time I ever saw Dave Clark, and he's just a fantastic guy. If you ever get a chance to meet him,
I met him for the first time, like 2 years
he's
ago.
fantastic, and he's so smart and all this stuff. Okay, so he's chairing it. Yeah, and there's some guy, and he's showing these transparencies like Tom was talking about, and they have like handwritten C code on it. That's what's on it, right? And they're in order, like, and he has little numbers on it. You know, it's like primitive stuff, right? But the thing is that people didn't want to, they were afraid of active queue management because, the router had a Z80 in it or something, and so you didn't want to, use any cycles any place you didn't have to, right? Yeah. And so Shanker, so this guy's up there. It's Scott Shanker. I blew that. So it's Scott Shanker, and he's shown this code that ran on a 386 or whatever it was, and it could do WFQ efficiently. And so I'm sitting there trying to look at it, and when it's happening, this guy gets up in the back of the room and says, no, we can make this more efficient. You can do it with like 5 less lines of code. And of course that was Van. And then I'm talking to the guy sitting next to me, and I'm going, I didn't understand that. What's going on? And the guy's trying to explain to me, that was Craig Partridge sitting next to me. And then Craig Partridge went home and sent me a copy of Perrick's thesis, a hard copy from MIT, because you had to buy it in those days.
Mm-hmm. Wow.
And so that's my first IETF experience. And of course I was hooked, right?
Yeah.
Because
my story is after that.
Oh, wait,
obviously my meetings were after that, but he showed up with a pack of transparencies like that, and it was a similar thing, like, wow.
Let me say one other thing about that era. Cool. It was during the IPNG era, if you remember what that was. So people really didn't know what to do with the next. So there were all these proposals, and these proposals had to get implemented because, of course, it's the IETF and stuff like that. And so one of the proposals was called Tuba, which, by the way, Peter Ford was involved with, which you told me last time. And I talked to him. He lives in something like that, right? Or he lives somewhere in Washington, one of those islands in the Sound. I was talking to him about this after you told me he was
93.
Yeah.
I remember.
But after you told me on the NLNOG that Peter Ford was involved with that, I asked him. So I talked to him a whole bunch about it. Anyway, so
cool.
One of the proposals for IP, the next IP, was called Tuba, TCP over UDP. And what was it?
TCP and UDP with bigger addresses. Ross Callan, author.
Oh. And who was the implementer? Because you had to implement it. Who was the implementer?
There was 3 implementers. There was Richard Colella from NIST that did a public domain one implementation. And then there was, I did a Cisco one, and Peter Ford did one in Windows, right?
Yeah, he was at Microsoft.
He at Microsoft at the time? Yeah. And so the 3 came together in 93, summer of 93 in Amsterdam to do an interoperability test. And go ahead, Dave, you finish it.
Cool.
No. That's all I wanted to say was, it worked. It would have worked. Right?
Yeah, you run TCP. And of course, this is where we struggle with layering and checksums at the transport layer and not having IDs versus locators. But of course, TCP had to be modified to know about these things called NSAP addresses, not IPv4 addresses, right? And that was our first taste at, TCP could run over multiple different network layers. That was the time to fix the checksum and to be able to have locator ID separation. And if we would have done that, IPv6 addresses today could have had locator ID separation as part of the architecture. We ignored that point, and it was sitting in our face right at that time. By the way, Dave, go ahead. Finish with Peter.
No. That was about it. But I mean, that was one of the places I first met Dino.
Yeah. So
Before
I have a
this was
I
before
have a
multicast.
yeah, I have a before multicast and a before IPv6 story and a before Tuba story about Cisco. And because you mentioned DECnet and IPX, you just triggered something in my brain. So, I saw this company called Cisco that built a multi-protocol router. And it meant at the network layer, there was all these peer protocols that would all do the same thing, encapsulate packets. And they would all have their naming system and their routing protocol. And it was like exactly the same code, but it was called IPX instead of Apollo domain, or, there was a half a dozen of them, right? And this is what motivated GRE, because people didn't have multi-protocol routers. They had single protocol routers, either an AppleTalk router or a Novell router or a
IPX
Cisco router
routers,
that
yeah.
just did IP.
I
And
remember
of course,
those.
I'm a simplification freak. And I said, Kirk Lockheed, employee number
Yep.
one at Cisco. I go, let's tunnel all this stuff over IP and people could then run all these protocols. He goes, Dino, you can't do that. He goes, simplification is great, but we're the only ones with a multi-protocol router. You don't want to remove protocols from the router. You want to add more because we want to keep our differentiation. So that was an engineer who did firmware, routing protocols, operating systems, line card stuff, and he still had a business acumen to him as well. And hence why I think Cisco was so successful in the early days, because not only the guys, they were kind of the Steve Jobs type of mind. They would understood technology, but they knew how to make money off of it too. And that was really made the difference between Cisco and a Proteon and an ACC and Wellfleet. Wellfleet was a little bit better, right? Of course,
Yeah.
at making money off of routers. But Kirk Lockheed, in fact, there's a recent interview just about a week ago, an interview about Kirk. So I suggest you guys go look it up. I think it's on, they're advertising it on Facebook, but employee number 4, engineer number 1, he was after Sandy Lerner and Len Bosak and stuff.
That was a great, that was a great interview. I read that.
Oh, you saw it? Yeah. Okay.
I saw that. And Dino, all of this is making me think. So in the 90s, my first job out of college was at a small company in Minnesota called Network Systems, which maybe you guys are familiar with. And
Hyperchannel.
I want to hear this. Yeah, exactly. And the rumor. So when I worked at Network
50
Systems,
megabit, that was screaming.
it was, like the rumor was, right? So I joined in 97, but the rumor was, like maybe this was like in the early 90s, Network Systems was going to do an acquisition, right? And they were like, they looked at two companies, and I, you probably know this. Like, I forget who they acquired, but they looked at Cisco and another company, and they went with the Token Ring company instead of Cisco, because they thought, well, Token Ring is the future. IBM mainframes.
IBM was doing it, yeah.
And it's they could have acquired Cisco. Like they literally evaluated Cisco, or who was it? The Token Ring company in the early 90s? Who they
Not
acquired?
the biggest Cisco mistake I've heard.
Proteon was a Token Ring company, but it wasn't them.
It wasn't them.
Proteon had a ProNet 50 and a ProNet 80.
Okay.
But the cool thing about Hyperchannel was the first parallel interface, which was cool. And I remember I was working at Control Data at the time, and we had 24-bit channels, and nobody could go screaming fast like 24 megabit. And then this company came out right out of Seymour Cray's neighborhood in Control Data's neighborhood called Network Systems, and they doubled the speed at 50 megabits. It's like, holy shit, this is screaming like a rape tape.
Yeah,
And
they did some amazing. Yeah.
I always think that that Token Ring versus Ethernet thing, it demonstrates something about human nature. Humans wanted Token Ring to work and win because it was deterministic. It was the non-deterministic nature of Ethernet that people just could not accept. And in fact, I remember. So I worked for this guy.
Dave.
I worked for this guy at U of O called Dale Smith, who was like, he's just really a visionary. I mean, he didn't become he's relatively famous, I guess, but I mean, that guy taught me so much stuff. And, I learned so much from him, and he always had vision about the future. You know Dale, don't you, Dino?
I think so. I think I met him
when
once.
you came with the Procateur. On the Procateur.
You may have introduced me to him. Yeah. But you're right, this Route Explorers packet, let's send a multicast packet on the entire network to find all the paths. Well, I was thinking about this when I went to Cisco and Ethernet, and I go, well, that Route Explorer packet is going to go everywhere in the network. That must mean you're trying to build a small network, right?
Yeah,
How do
not
you
a
do
big
this?
network. Yeah.
Yeah.
I
So
was
anyways,
building my first job. I was at a little company called Zyplex, who had actually competed with Cisco at the time,
oh yeah, I
and
remember. Yep,
we
yep.
made a router that actually a router bridge. Remember a routing bridge?
Hmm.
A
Yeah,
router,
Yep.
a router,
routers.
A browder.
Yeah.
a router, or
Routers. Yep.
whatever, right?
No, they really called it that.
They
Yeah,
did. We really
Yeah.
called it
I
a
worked at
router.
three. I worked at 3Com at the time, and we called it a browder. Yep.
Exactly.
Yeah.
And it
But
was
it was just
interesting.
funny how
I mean,
how.
who
Go
was
ahead.
the
Go ahead.
marketing genius who came up with that? I mean, seriously.
Yeah, I don't know. It was really funny because we had a hub group. Remember
Better than
we
a
all
ridge, a browder or a ridge.
a bridge, yeah, a ridge.
Yeah.
I remember we had hubs. We had a whole product line that were
Oh
hubs,
yeah.
and then I was in the router team. It was only like 12 of us, and there was somebody came down from upstairs one day and said, "Hey, you guys need to build this token ring thing and bridge Ethernet to token ring." And we were
Oh
like,
yeah.
"Wow, this
Uh,
is crazy."
that was a
But it,
technology challenge that the whole industry went through, right?
yeah,
802.2, 802.3, 802.4,
Yeah.
802.5, right?
Those
It goes
those
on and
types
on and
of
on.
translations, like think about how crazy it is. When I was at Network Systems, we were translating ESCON to fiber channel, if you can believe that.
Oh,
And it
yeah.
was like, I mean, just like all these protocols, and you got to translate this and do that and try to. It's
So
Well, here
when
I go again.
yeah,
LT versus 5G,
that's
yeah,
right?
right.
Why don't you just run IP over these
just
data
run
links?
IP.
Okay,
Yeah,
here we go
Exactly.
again. This is 40 years later, and people still want
no,
to keep their
It's
layer
the
two
same.
no,
technology and all the
no,
Exactly.
complexity.
All the
you know, I think it,
complexity.
I think it's again, it's like a human nature thing. I don't think
Yeah, it
people,
is.
I don't think people go, oh, I want
Want to?
complexity.
I want to.
I,
Yeah,
I, I
right, right.
think, I think what they like is things they understand. And so if you
I
have
think you're
something
right. I think they stumble into the complexity just like people stumble into success as well. I think it's just
well,
this
nobody
kind of,
plans for
you know,
oh,
complexity on
well,
purpose. I
yeah,
mean,
yeah,
that's
right,
nuts.
right, right.
uh,
You
But it's
make
like the
trade-offs,
BFD
and
thing. Like,
sometimes you think it's worth it. Yeah.
let's add one more
Hmm.
thing because it's worth it, right? Let's add
so I had
one more thing, and
And it benefits this company versus this one, or yeah,
right.
yeah, yeah.
okay, so the
I like,
internet brought me another fantastic thing that had to do with complexity. So the people I kind of fell in with, I wanted to work on a really big network. When I was at Cisco, Kyle, like in the, it would be in the Tony Bates
Oh yeah.
era, you know.
Era.
Yeah.
Okay.
Hmm.
Yeah.
So that was during your
By the
Sprint
way,
time, almost,
but
right?
so I wound up going to Sprint. I just want to say a nice thing about Tony Bates. I told him, uh, uh, I want to go work in a big network, and I'm probably going to leave Cisco because I want to do that. And you know what he said to me? He said, I mean, I never had anybody treat me like that. He said, let me look at all the offers you get. I'll analyze them and tell you what I think. And so,
Awesome.
he was helping me leave
Very
the
nice.
company. And that's like a real mentorship kind of thing, right?
Yeah.
Yeah.
I never got that from anybody else. It was like, it was amazing. And then when I came back, he was the first guy to say, yeah,
Well, remember, you did this for me when I went to BT. We had the same
yeah,
conversation.
yeah. But I mean, I
Yeah. And Ward
really
did the same
remember
thing.
that.
Like,
And you know
yeah,
what? It was really interesting because he invited Sue's meeting
yeah.
where we talked about it
Oh, cool. Yeah.
because he knew
Nice,
how
nice.
important my family was to me.
But you
And he
come
did all
back
that,
too. You came back to Cisco with all of that knowledge of how the
amazing,
sausage factory
amazing.
actually
And
operates.
he was an example of someone who went from the network to a vendor, right?
Yeah,
Mhm.
the first
Dave.
time I worked with Tony Bates, and Joe Snyder's just beat the crap out of me on this, but he calls me one of the what does he call it? RPSL clowns, because I wanted to work with Tony and all those people who were at the RIPE NCC at the time, like Daniel Karenberg and all those kind of people. And so they were working on RPSL, and I asked them, "Can I work on it?" And they said, "Yeah, sure." It was a different kind of era where people didn't try to keep you out of
Right, right.
things. They were kind of like.
It was small enough that people were trying to include more.
So I just wanted to work with those people, and so I got involved with RPSL and spent years on it. And that's where I went. I
Remember,
met
that's
people
how the
like.
IETF used to be too. When I first showed up, and I met you guys, you were just some bodybuilder in shorts, and you were like, hey, Let me show you around. You know.
Yeah. No, but Dino, that's where I met Cengiz on RPSL.
Yeah.
Yep.
And like, and that guy
He's
is really
brilliant. Yeah.
he's a
Oh,
really,
yeah.
really smart guy. And he wrote this thing called IRR tools, and I used it with RPSL. So what this thing did was it queried the IRR, which it was at the time the only routing database around. It queried the IRR and built Cisco and Juniper AC, well, they weren't ACLs, they were prefix lists. They were prefix lists or whatever, so that you could automatically build your routing.
Configure router, yeah.
Could automatically build your routing protocol. That's I think what Cengiz did for his thesis.
Wow, that's cool. That
By the
was
way,
when the routing table was much smaller.
He just became a fellow at where is he at? I don't know, wherever he's at.
Oh.
VMware? No.
No. It's
Did he go to a vendor or?
Yeah, it's a vendor.
He did the Route Explorer. He did a Route Explorer stuff.
Yeah, well, he was at Packet Design with Van for years and years. Anyway, you know, I just stumbled. That's another one of those things where I really wanted to work with these guys, and I just tripped on it and fell on it, you know. And it's like
you're like, wow, look at this. No,
I mean, it's that, and also the fantastic luck. You know, what kind of luck do you have to have?
Yeah, I mean, a lot of people just say, I can't believe you were part of the internet during the heyday or whatever. And it was just this time and space thing where we were there, we were engineers, we do what we're trained to do, and we were able to be in a point in time, you know, this huge continuum of time where we were able to be part of this. And so we were just doing our jobs. It really wasn't anything special. Yeah, and it was that time.
I agree.
And
I agree with you.
You know?
I agree with you, and I don't disagree with
thing. Yeah.
I agree with you, and I don't disagree with anything you said, but I don't take credit for my good fortune. I understand. I was just really lucky.
You were really in the right place,
really lucky.
in a lot of ways,
just for the reason you just said.
Maybe we should
right
take
place
credit
at the
that
right
we didn't
time.
screw up. We didn't screw up the opportunity. Maybe that's what we should take credit for, right? That we could have blew it, right? But what we did is we embraced it. We're open minded. We did what we did, and you know that community was great. And I mean, Dave, you got to tell the story about how we used to GDB core routers. Those days are gone, right?
Okay.
I mean, when a router crashed in the middle of the internet, you had to GDB
that thing.
So
you'll love this. You'll love this. So I'm working at U of O, right? And so I'm an enterprise network engineer. You know, and you know, I'm an enterprise network engineer, and I get this idea that okay, we're on the M-bone. And, you know, I'm in the multicast mindset. I'm meeting people like Steve Deering. I can't believe it. And I'm learning so much from these people. And so we had M-bone. And what the M-bone thing, it was okay, but it couldn't scale because forget about the, flood and prune, all that kind of stuff. Forget about that. All of the endpoints on the network were workstation desktops. And that's not going to work in an enterprise, because you'll need 100,000 tunnels into your, thing. So into your enterprise. So I asked Dino, I said, hey, Dino, what if we built a PIM, or you probably told me this after I told you what the problem I was trying to solve with. I don't know which way this all went. But, what it came down to was, can we build a DVMRP to PIM stub router that you put on the edge of your enterprise, where you home a DVMRP tunnel onto this one router, and it explodes it out the other side as PIM. So all the people who have multicast capable
aggregation
things can just get the multicast packets by sending joins and all that stuff.
Mm-hmm.
And so we started with a replication server.
Yeah, right. Well, not anymore.
Not anymore.
So we start building it. So we start building it, and it's in the days of, I don't know if you guys remember this, but the AGS is an AGS Plus. So it's a Motorola, it's a multi-bus card cage with a Motorola 6020, right? 6820, right?
6820.
16 megs. And then it has these kind of different cards you shove in it for whatever interface you want. That's what this thing is. And this is routing everything on the campus. And well, this was running the internet at the time, to be quite frank with you.
with the capital
And
I, but it was small,
all of it,
smaller.
right? Well, okay, there was probably some Wellfleet stuff around, but so anyway, we're starting to work on this stuff, and as is typical with Dino, if he has a bug, he will never accept it until you prove it. You have to, you have to prove it's a bug, even down to here's the code, show me where the bug is. You did that to me so many times.
Well, then you can fix
it. Anyway,
I was just trying to get information out of you, right?
Yeah,
so
right,
I wouldn't
right.
fix something. I wouldn't fix something that I shouldn't have fixed, right, or broke, right?
Yeah, right. So anyway, we have some bug. We can't figure it out. And Dino goes, I need to GDB the kernel. Okay, so now this is a border router on our campus network.
running the whole place.
We're running the whole place.
Let's freeze it for a second.
Yeah. So I figure, I go, what do I have to do?
There's a huge lesson here, but keep going, Dave.
So what I have to do is like, how do I do it? And somehow Cisco had this. I don't really know what this was. Maybe you can fill this in. You could put a modem on the console port.
Yeah, and that's how you got to it, right?
And that's how you got to it.
We did that remotely.
You could GDP through a terminal server port, or you could GDP over TCP. Greg Satz built that, so you could actually do it inline versus out of band. And Dave, I think the part of the story you're talking about is we did it in band, because that's the funny thing we want to talk about. Right?
So we built this whole thing where what happened was Dino could actually set a breakpoint. Okay, so now this is GDB, your familiar thing, and you go, I need to set a breakpoint here. It's like, well, that stops the router.
That stops the whole router, man.
And guess what? The breakpoint was done in IP, and I was using a TCP connection to get access to it. So when you set a breakpoint, it stops execution.
It stops the whole damn thing, yeah.
And of course, Dave can't fix it gracefully. He's got to power cycle it, right?
Reboot it.
Good.
Reboot it.
Good. And good thing he was
the
physically
campus.
where the router was too.
But,
right?
that's the kind of stuff.
Too, right?
That's the kind of stuff we had to do to learn this, right?
That's
you could
the
never
kind of
do
crazy
it
stuff
today.
we had to do,
But the lesson here is that these overlays have to run over bits and boxes and strings and real bits and real electronics, and people abstract so much over the real network that they forget that they're running over real hardware. Yeah, and of course they heavyweight it so much and I'm not just talking about us building network layer overlays, but application overlays and like this Istio stuff that we're running now, and these service meshes and all this stuff that's running, and cloud computing, and we're running
about Istio,
overlays
Dino.
over cloud over. It's just crazy.
Dino, Istio, we have Kyle Mestery here with us.
No.
Never going away.
I mean,
never.
People are
Ward
building
for
levels.
that.
Yeah, people build levels of abstraction to solve real problems,
right.
but when do we stop modifying BFD? Is your point, Tom? Right? So.
That's right.
Hey, on that thought, guys, we're a little over on time. We're gonna have to have you guys back on here. This was a fantastic conversation.
Yeah, I think there's more to dig into the next time for sure.
There's more here. Yeah,
It's fun, right?
Yeah.
It's fun. I didn't realize it until Job, did it last time. How much fun this would be, right?
It really is.
I mean,
yep.
I just didn't get it.
This is one of the things we really miss about going to conferences.
But also all we learned, all we learned. How much we learned.
Yep.
Just unbelievable.
30 years, there's a lot of learning, right?
Let me just say one thing before we cut it off.
Not only is there a lot of learning, there's a lot of new mistakes you make too. The same mistakes you make over and over again. Sometimes it takes a while to get it
No
through.
doubt.
But,
no doubt.
Yeah.
But let me just say one thing, is that there were this intrepid band of internet pioneers, including Dino, people like Steve Deering,
Van, Leisha, Deborah Estrin, Dave Clark.
Bill Fenner. These people had the vision that you could run video and audio over the internet. And while this array of massive telcos were fighting them and telling them it couldn't be done and all that stuff. And those people, not only were they brilliant and very skilled, they were the people who wrote all the code and deployed it and all that kind of stuff. Steve Kasner,
he's in that group for sure. Absolutely.
Yeah, for sure, 100%. Allison
you're right.
Menken.
When I was
Allison
at BT, I
Menken.
remember somebody telling us you
McCann.
can't run video over the
McCann,
internet because there's no
Yeah, but
section layer.
those people were,
Well,
this
you're
is what I want
dropping
to say.
packets. That's a terrible thing to do.
Right.
The internet scales because it can drop packets, not because it can forward
But
packets.
video is CBR.
That's a
Oh my God.
robustness feature.
Yeah, all that stuff, Tom,
Yeah.
all that
crap,
stuff.
yeah.
And those people, they persisted not only, psychologically and emotionally and stuff, but intellectually and in, their engineering skills and all that. And that is why.
They were practical too.
That is, but
Mhm.
that is why we're here doing this today.
Yeah, that's why this stuff all works still.
And you can credit them, including you, Dino, you're one of them.
Yeah.
For that.
Well, it's thousands of people. There are a bunch of core original pioneers, but there's thousands and thousands of people that made the internet work and is continuing to do it in its current form, which is harder than what we had.
It's true. That's true. But
we had simpler system.
I'm talking specifically about the M-Bone and the idea that you could send video and audio over the internet because
Absolutely. Yep.
Because the people,
we're doing it right now.
The people like in
shifter,
the people like in Vince era, I think they always thought it was possible, but they had this vast array of giant telcos fighting them, and they persisted. They persisted.
And look how long we've been working from home using all our tools that we ran over. And now, just since March, everybody realizes there's this thing called Zoom, and it's just like this great innovation. It's just like, it's been around for a long time. You're just being forced now to use it, and you're learning how to use it, and you actually like it, right?
Dino, Susan, I had a discussion about this. I think the innovation in Zoom is, first off, send a URL, and that's it. You can just join with the URL.
No accounts. Earlier. You send a
accounts.
And
no accounts. No logging in. None of that. And the second thing is, there's a little kind of brilliance in the way that they were able to lay out the screen. So somehow you could start to think about how to scale that. Right. Mm-hmm. It's not perfect. But it's a lot better than what we've seen in the past.
Yes, agree. And the UI is simple.
Yeah.
Average people could,
Yeah.
But we still find people that are new to Zoom that struggle with, audio and talking on mute and things like that. But those things are getting sorted out now. People know people are learning about what kind of lighting to use and how they should look and, where they should position. There's a whole new kind of demographic to all this thing. So it's kind of interesting.
And it's kind of a positive thing that's come out of it too. It's taught people that you can work from home part of the time, all the time. This gets into the Dave was talking about earlier off camera about, the ecological impact, the positive ecological impact of not flying anywhere every day, and all of that stuff. It's.
So
did you read the paper I wrote about the carbon footprint that each of us have when we go to the IETF?
Yeah, I read that. Yep.
It's like 10,000 pounds.
Yeah, it's
like 10,000 pounds of CO2.
Maybe
it's like ridiculous.
IETF should eat its own dog food in some ways, right? Do this.
Yeah, I mean, so that's kind of one of my big takeaways just from listening to you guys. So the early on was such a small core of people that were able to collaborate, and thanks to the growth and scalability of obviously the internet, that's now it's exponentially exploded, and anybody can collaborate with anybody. Anybody can, you don't have to send me a CD with code on it, which is just mind bending these days, right? So I think it's cool.
Hey Dave,
the hardest thing to deal with today is that you have to do time zone management. That's the hardest thing to deal with today.
Right.
Dino,
time zone management.
Where I got the Spark 5 Solaris 5.0 code, and I'm not revealing anything that I shouldn't hear. You know where I got it? Eric Nordmark and Alan Romanow.
When they were working at Sun at the time.
Yep.
Yeah.
Cool.
Yeah, and those guys, those two are part of that inner circle too. I would say they were around and developed quite a bit of technology. Yep.
So just to be clear, do it. Alan Romanoff wrote the DVMRP implementation. The daemon that ran on Sun on the what was it? It was Sun OS 4, 4.1 and 4.2 and all that kind of stuff. And then Eric Nordmark was a kernel architect for and the implementer for the multicast stuff.
Yep.
And he actually, you know what? At that time, when I looked at the code in Solaris 5.0, he also had that. Steve had this idea that you could do source route tunnels. Remember that?
Yep.
Mm-hmm.
Yep.
It got deprecated over time, but that code was in there.
We have it in GRE, and nobody set the enable bits on it, so because we wanted to do AS hop routing, right? So
yeah, well, the code was in that.
And by the way,
that
and now
Eric
we
had
have
implemented
something
it.
that's called segment routing, right?
Yeah.
So it's the same concept.
It's
just a
it's
new
exactly
name, new reason, right?
You beat me to it. It's exactly the same thing. It's source routing, right?
Yeah.
Mm-hmm.
You know?
Yeah.
But that code was in there, and that was the first time I understood what Steve was talking about with the source routed tunnels.
But this one's different because segments are different than source routes.
Yeah,
of course.
They're called something else. That's why they're different.
You got that.
Hey guys, we're gonna have to wrap it on we're getting over on our
time. Okay, no worries.
budget for time.
Well,
Thanks so much, guys.
Thank you guys
really
for having us
appreciate
on. It's
you
been
guys.
great. It's been great.
It was so fun.
And it's great to
nice
see you
to
guys.
see everybody too.
Yeah,
it's great to see you guys. Great to see you guys.
And we
glad
like
to do
I said
it again. Glad to do it again if you want.
Yeah.
We will have you
Great
on
fun.
the new year at some point for sure. Thank you very much, guys.
Great. Good luck, guys, and keep in touch.
Thanks
and keep doing the podcast. Remember the importance of science journalism and engineering journalism. What you're doing is important. You got to educate people. We got to educate people.
Absolutely.
You heard it.
We don't want them to make the same mistakes. You know the definition of insanity, right?
Yes.
Right.
On that
if
note,
you don't tell them the mistakes, they're going to be making
they're
them.
going to keep going, right?
So,
On that note.
Thanks again, you guys.
Thank you, guys.
Thanks again, guys. Take care. Bye-bye.
Bye.